Hi, I'm George Woodbury from College of the Sequoias, and in this video we're going to talk about function operations. Now, just like you can add, subtract, multiply, or divide numbers, you can do the same thing with functions, and so that's what we're going to do here. In this first example, we're not just going to do those operations, but we're going to evaluate as well. And there's two ways that we could do this. For instance, the first one says find f plus g of 5. We can first find f plus g of x by adding their formulas together and then plugging 5 into that. Or we could start by finding f of 5 and g of 5 separately and then adding those. And so in this case, I'm going to do the separate function evaluation rather than combining them and evaluating. So first, I need to find f of 5, which is 2x squared plus 3 is the formula for f. So that's 2 times 5 squared plus 3. 5 squared is 25. 2 times 25 is 50. 50 plus 3 is 53. Then we'll do g of 5, which was 4x minus 5. I'm going to put in 5 for x there. 4 times 5 is 20, minus 5 is 15. So f plus g of 5 turns into f of 5 plus g of 5, which we found to be 53 plus 15, or 68. Now, just for this one example, if I had combined them first, if I had added the formula for f of x to that of g of x, we would have had 2x squared plus 4x minus 2. And if we were to substitute 5 in for x there, that would have been 2 times 5 squared plus 4 times 5 minus 2. 2 times 5 squared is still 50 from earlier. 4 times 5 is 20. So we'd have 50 plus 20 minus 2, which is also 68. So you can get the same result either way. But for this example, the rest of them, I'm going to do the individual functions first and then the operations second. Part B, we're looking for f minus g of negative 3. So I need to find f of negative 3 and g of negative 3, and then I'll subtract those two results. Substitute negative 3 into the formula. 2 times negative 3 squared plus 3. That's 2 times 9, or 18 plus 3, which is 21. When I substitute negative 3 into g, that's 4 times negative 3 plus 5, or negative 12 plus 5. That is negative 7. So f of negative 3 minus g of negative 3 is 21 minus negative 7. That's the same as 21 plus 7, or 28. For part C, we have f times g of 0. So we'll begin with f of 0 and g of 0, and then we'll multiply those results. F of 0 is 2 times 0 squared plus 3. That's 0 plus 3, or 3. For g of 0, that's 4 times 0 plus 4 times 0 minus 5, which is negative 5. So f of 0 times g of 0 is 3 times negative 5, or negative 15. All right, last example, we've got f over g of 8. So I need to find f of 8 first, g of 8 second, and then I can divide those two results. F of 8 is 2 times 8 squared plus 3. 8 squared is 64. 2 times 64 plus 3 is 131. 2 times 64 is 128 plus 3 more. G of 8 is 4 times 8 minus 5. 4 times 8 is 32. Minus 5 is 27. And so f of 8 over g of 8 is 131 over 27. that fraction's already in lowest terms because the only factors of 27 are powers of 3, but 3 does not divide into 131 evenly. Now, as I mentioned, you could have combined the formulas first by subtracting, multiplying, or dividing them, and then substituted after, and you'll get the same result. In the second problem, we are going to work with those formulas and find the general function. Notice that it says f plus g of x, f minus g of x, f times g of x, and f over g of x, all the same. We're going to find the general formula rather than substituting in a value. We really don't have any choice of how to proceed here. In part A, f plus g of x is the same as f of x plus g of x. And now we're going to replace each function by its formula. F of x is x squared minus 2x plus 7, plus g of x is 2x plus 9. And when we're adding polynomials, we just need to combine like terms. There's just the one x squared term. Negative 2x plus 2x add to be 0. So all we have left is 7 plus 9, or 16. For part B, it's the same problem, except we're going to subtract. F of x minus g of x equals x squared minus 2x plus 7 minus the quantity 2x plus 9. And again, those formulas are just coming from above. That's what f of x and g of x were defined to be. I need to distribute that minus sign through the second set of parentheses. That gives us x squared minus 2x plus 7 minus 2x minus 9. And then it's time to combine like terms. That's going to be x squared minus 4x, negative 2x and negative 2x. Positive 7 minus 9, that's a negative 2. So we are left with x squared minus 4x minus 2. F times g of x means that we need to multiply these formulas. So that's going to be f of x times g of x. F of x is that trinomial x squared minus 2x plus 7. G of x is 2x plus 9. And now we need to multiply out using that FOIL style of multiplication, distributing each factor in the first set of parentheses to each in the second. Let's see, x squared times 2x is 2x cubed. X squared times 2x is plus 2x, x squared times 9 is plus 9x squared. Then we distribute the negative 2x through. Negative 2x times 2x, that's negative 4x squared. Negative 2x times 9, that's minus 18x. Finish by distributing through the positive 7. 7 times 2x, that's plus 14x. And 7 times 9, that's plus 63. Now we can combine like terms, and we're left with 2x cubed. Positive 9x squared minus 4x squared, that's plus 5x squared. Negative 18x plus 14x, that's minus 4x. And then the constant term plus 63. Division looks like it could be the most difficult. It's actually one of the easier ones usually. This is going to be f of x over g of x. And we can put those formulas in. X squared minus 2x plus 7 over 2x plus 9. And the only thing that we might be able to do here is to simplify by dividing out common factors. However, x squared minus 2x plus 7 does not factor as a trinomial, so this is as far as that one can go. Let me change the orientation here real quickly, because for the last part, it says, give the domains of the functions in parts A through D. Now, parts A, B, and C, the domain is the set of all real numbers because there's no division involved, there are no square roots involved, so we can plug any number we want in to there. For part D, though, and I'll do that here, we can substitute any value into f of x. It's just a polynomial. Same thing for g of x. But when we're dividing those two, we know that the denominator cannot be equal to 0. So we've got to figure out what value of x makes 2x plus 9 equal to 0, and then we need to exclude that from the domain. Subtract 9, divide by 2, x equals negative 9 halves. That means that negative 9 halves cannot be in the domain. And the way that we write that, negative infinity, comma, negative 9 halves, parentheses, union, negative 9 halves, comma, infinity. That is the domain of that last function. All right, that's it for operations with functions. Again, you can add, subtract, multiply, or divide the formulas. Or if you're given a value, you can substitute that value in and then do the operation. Or you could use the formulas to do the operation first and then substitute one time at the end. Anyway, in the next one, we'll take a look at an expression called the difference quotient.